everyone, my name is Giovanna Proença and today we're going to talk about topics of AP Computer Science exam. So today we're going to talk about octal system, alright? In the previous videos we already talked about abstraction, binary and hexadecimal. So let's finish this idea of abstraction and put all the exercises together with these three systems, okay? So let's see. Octal was widely used in computer as a compact alternative to binary in machine programming languages. Basically, the octal system contains 8 numbers, so we normally use numbers from 0 to 7, alright? And it's different than binary, because in binary we normally use 2 numbers, 0 and 1, and different than hexadecimal, where we use 16 numbers from 0 to 9, and then letters A to F. So in here, basically, we're working with only 8 numbers, okay? So the big question we're gonna answer right now is how can we convert octal into a decimal? So the idea is pretty much the same as what we did for binary and hexadecimal, alright? But the big difference here is that for binary we were using 2 power of a number because it's base 2. For hexadecimal we were using 16 power of another number because it was base 16. And right now for octal we're gonna use 8 power of something because octal is base 8. Alright, so let's see the following example. Let's suppose we want to convert the number 107 to decimal. The first step we have to do is creating a flexible table with as many columns as the number of digits that our octal number has. In our case, we would do 3 columns since we have 3 digits in 107 in octal. Then, write the values 1, 8 and 64 that represents 8 power of 0, 8 power of 1 and 8 power of 2. Then let's multiply the respective digit of the octal number with the power of 8. In our case we would do 64 times 1, 8 times 0 and 1 times 7. Now we're going to sum the result of the multiplications and this will be the value in decimal. In our case it will be 64 plus 7. Finally, we found out that 107 in octal system is represented by 71 in decimal. So now that we learned how to convert octal into a decimal, how can we do the other way around? Let's see the next example. Let's suppose we want to convert the number 120 into octal. The first step we have to do is creating a flexible table with enough columns until the number in the row is just bigger than the number we are converting to. In our case, we would write the values 1, 8, 64 and 512. That represent 8 powers of 0, 1, 2 and 3. Then, let's work with the largest number that is still smaller than the target number, in this case 64. Now we have to multiply 64 by the highest number that fits our target number. In our case, 1 times 64 is equal to 64. This means that we know the first octal value. Subtract this multiplication by our target number. In our case, we would do 120 minus 64, having as a result the value 56. Now we're going to do these 2 steps again, in which we're going to find out which number multiplied by 8 returns 56. In this case, it will be number 7. Subtract this multiplication by the remaining number. In our case, we will do 56 minus 56, having as a result the value 0. This means that we know the second octal value. Then we're going to find which number multiplied by 1 returns 0. In this case, it will be number 0. This means that we know the last octal value. Finally, we found out that 120 in octal system is represented by 170 in decimal. So now that we saw all these concepts and we understood these examples, let's do some exercises to practice. So let's do the first exercise. So basically in here we're gonna convert 600 in octal to decimal, alright? So basically we're going to check how many digits our octal number has, in this case 3, alright, 6, 0 and 0. And we're gonna create the first row of our table where we're gonna contain 3 results of 8 power of something. So we're gonna start from the right, 8 power of 0, that it's 1, 8 power of 1, that it's 8, and 8 power of 2, that that is 64. Then we're going to multiply these results that we got by the digit that we have in octal. So we're gonna do 6 times 64, 0 times 8, and 0 times 1. And in the end, we're gonna sum all the multiplications. So we're gonna have 6 times 64, and the other ones are plus 0, because every other number multiplied by 0 is 0. And in the end, we're gonna have 384. Okay? The second exercise, we're going to convert 235 in decimal to octal. So what are we gonna do? Here, we're going to create a table, all right, where we're gonna put all the numbers until we have a number that its power of 8 is greater than the decimal. So for example, we're gonna use 1 that it's 8 power of 0, 8 that it's 8 power of 1, 64 that it's 8 power of 2, and 512 that it's 8 power of 3. So now we have all these numbers in here. We're gonna get the largest number that is still smaller than the decimal. So the largest number is 64 because it's still smaller than 239. Then we're gonna multiply 64 by 3 because this is the maximum number that we can have that contains 239 contains this number. So in this case, we're going to have 3 times 64, all right? So 3 will be the first octal number for our conversion. So then we're gonna subtract 3 times 64 by 239. So we're gonna have 239 minus 192, that it will be equals to 47, okay? Now we're gonna take a look at the next value. So we're gonna check which number that times 8 will be the largest number that contains, that 47 can contain. So this will be 5 times 8 because this is 40, all right? And 40 fits in 47. So we're going to have the second digit in octal, that will be the number 5. Then we're gonna subtract the remaining value for our decimal, that is 47, minus 40, that it's 5 times 8, and this will give us 7, okay? And finally, we're gonna check which digit will be the last digit in our octal. So which number times 1 will return us 7, and this number is 7 itself. So in the end, our octal number will be 357, and this is the same thing as 239 in decimal. Okay, let's see the next one. The third exercise, it's pretty similar to what we did last video, all right? So we're gonna order the numbers from lowest to highest, where we're gonna have the numbers 11 in hexadecimal, 11 in decimal, 11 in binary, and 11 in octal. So what are we gonna do? We're gonna convert all these numbers in different systems, and we're gonna convert in one system that we can check which one is the highest, all right? So the easiest conversion that we can do is for decimal. So let's convert hexadecimal, binary, and octal to decimal, okay? So the first thing we're gonna do is we're gonna convert the number 11 in hexadecimal to binary, okay? So since 11 has only 2 digits, we're gonna do the 16 power of 0, that is 1, and 16 power of 1, that is 16. Then we're gonna multiply the digits with this result, so 1 times 16 plus 1 times 1, and then we're gonna sum this multiplication. So we're gonna have 16 plus 1, that will be 17. So 11 in hexadecimal is the same thing as 17 in decimal, okay? Then 11 in decimal is still 11 in decimal, all right? And 11 in binary, we're gonna do the conversion. So since we have 2 characters, 2 digits, sorry, we're gonna do 2 times 0, that it's 1, and 2 times 1, that is 2, and we're gonna multiply. So 1 times 2 plus 1 times 1, we're gonna have 2 plus 1, and this will give us 3. So right now we have the value that 11 in binary is the same as 3 in decimal. And now we're gonna do the last conversion to octal, octal to decimal. So 11 in octal, here again we have 2 digits, so we're gonna do 8 power of 0, that it's 1, and 8 power of 1, that it's 8, and we're gonna multiply 1 times 8 and 1 times 1, and in the end we're gonna sum this multiplication. It will be 8 plus 1, that it's 9. So basically, if we order from lowest to highest, we're gonna have binary first, the lowest, then octal, then decimal, and the highest value is hexadecimal, okay? Now we're gonna do the same, all right, but in the other way around, but with the exercise 4. So orders the number from highest to lowest, and the numbers are AB in hexadecimal, 109 in decimal, 1010 in binary, and 109 in octal. So here's pretty much the same. We're gonna convert all the systems into one system, and then here we can compare the numbers. All right, so let's convert hexadecimal, binary, and octal to decimal, that it's easier for us. So the first conversion, we're going to convert AB in hexadecimal to decimal. So we know that we have 2 characters in hexadecimal, so we're going to create the column with the row with 2 columns. So we're going to do 16 power of 0, that is 1, and 16 power of 1, that is 16. Then we're gonna multiply A and B with 16 and 11 and 1, okay? But what is A? The value of A is 10, so we're gonna do 10 times 16, and the value of B is 11, so 11 times 1, okay? So we're gonna do 10 times 16 plus 11 times 1, and it will give us 171. Okay, so we know the first value. Then the decimal, we don't need to convert anything because this is already the system we're gonna use. That is 109. Then we're gonna convert binary, that it's 1010. So since we have 4 digits, we're gonna create 4 columns in our table. So we have 1, 2, 4, and 8 that are the respective powers of the numbers, okay? And we're gonna multiply with the digits of the binary. So we're gonna do 1 times 8, 0 times 4, 1 times 2, and 0 times 1, okay? And in the end, we're gonna sum this multiplication, so it will be 8 plus 2, that is 8, that is 10, okay? So right now we have 3 numbers already. Now let's check the octal, okay? So 109 in octal is the same, has 3 digits, all right, like we can see. So we're gonna create a table where the first row will have 3 columns. So 8 power of 0 is 1, 8 power of 1 is 8, and 8 power of 2 is 64. Then we're gonna multiply the digits with these respective powers, 8 powers of something. So it's going to be 1 times 64, 0 times 8, and 9 times 1. And when we sum all of this, we're gonna have the number 73. Okay, so with all of this, we know that the lowest value is binary, then octal, then decimal, and the highest number is hexadecimal again. All right, so now let's see the next problem. So now that this is the last video for representing these conversions into different systems, we're gonna convert some numbers into other ones, all right? So the exercise 5, we're gonna convert EE in hexadecimal to octal, sorry. So how are we going to do this? The best way of doing this is converting hexadecimal to decimal and then converting decimal to octal. So we're gonna do in 2 steps, okay? So the first step, we're gonna convert hexadecimal to decimal. So EE is the same thing. We know that we have 2 characters in the hexadecimal, so we're gonna create a column, a row with 2 columns, okay? So we're gonna do 16 power of 0, that is 1, and 16 power of 1, that is 16. And then we're gonna multiply these results with the characters that we have in hexadecimal. So we know that E is the same thing as 14. So we're gonna do 14 times 16 plus 14 times 1. And when we sum all of this, we know that the number in decimal is 238, okay? So now we're gonna convert the decimal number into octal, all right? And then we're gonna get the answer. So basically, we know that the number is 238, so we're going to create a row in our table until we have a number that is highest than our target number. So we're gonna have 1, 8, 64, and 512, that it's 8 power of 3. Then we're gonna check which number that fits inside our number 238, which number that times 64 fits 238, and this way we're gonna find the number 3. So 3 times 64 is 192. So this fits 238. All right, so we know already the first digit in octal. So then we're going to subtract 238, that is our target number, minus 192, that is 3 times 64, and this will give us 46. Then we're going to the next number and we're gonna find out which number times 8 still fits, which number is the highest number that still fits the remaining value for our target number. So which number that times 8 still fits 46, okay? So if we think about 5 times 8, it's 40, so this is the highest number that we can use for the second digit. So this will be our second digit, the number 5, okay? So then we're gonna subtract 46 minus 40, all right? And this will return us 6. Then the last digit, we're gonna check which number times 1 returns 6, and this is the number 6 itself. So in the end, we're going to have, we know that EE in hexadecimal is the same thing as 356 in octal. Okay, now we're gonna do the other way around on the exercise 6. So we're gonna convert 556 in octal to hexadecimal. So here's the same trick. We're going to convert octal to decimal and then decimal to hexadecimal, all right? So the first step, octal to decimal, we know that the number is 456. So we're gonna create a table where we have 3 columns because we have 3 digits in our octal number. And we're gonna do 1, 8, and 64, okay? Because octal is it's 8 power of something. Then we're going to multiply the digits of our octal with the respective columns that we just created. So it will be 4 times 64, 5 times 8, 6 times 1. And then we're going to sum all these numbers. So we have 256 plus 40 plus 6. And in the end, if we sum, we have the number 302 in decimal, okay? Now the second step, to find the hexadecimal value, we're going to convert 302 into hexadecimal, all right? So here we're going to do 1 row in our table with all the numbers that still fit 302. So we have the number 1, 16, 256, and if we do 16 power of 3, we're gonna have 4096, all right? So we can kind of remove this 496. Then we're gonna check the following. Which number times 256 still fits 302? So we know that it's the number 1. So number 1 will be our first digit in hexadecimal, all right? And we're gonna subtract 302 minus 256, and this will return us 46, okay? Now we're gonna check the next number, so which number times 16 it still fits 46, okay? So this number is 2, 2 times 16 is 32, and then we're gonna subtract 46 minus 32, and this will return us 14. So right now we know the second digit in hexadecimal. And finally, we're gonna think which number times 1 return us 14, and this number is 14 itself, okay? But 14 doesn't exist in hexadecimal. 14 is represented by the letter E. So in the end, our hexadecimal value is 12E, okay? Let's see the next one. So now we're gonna convert a binary number into a hexadecimal. So we have the binary number 111000, and we're gonna convert to hex, all right? So to do this is exactly the same idea as we were doing before. We're gonna convert the number in binary into decimal and then decimal into hexadecimal, okay? So since we know that our binary number has 6 digits, we're gonna create a table with 6 columns. So we're gonna have from right to left 1, 2, 4, 8, 16, and 32, okay? And then we're gonna multiply by the digits that we have in our number. So 1 times 32, 1 times 16, 1 times 8, 0 times 4, 0 times 2, and 0 times 1. So in the end, we're gonna sum what the result of these multiplications, that it's 32 plus 16 plus 8, and the result is 56, all right? So now that we know the number in decimal, we're gonna convert this decimal number into hexadecimal. So 56, we're gonna create a table with the columns with numbers that are that fit 56, so we have the number 1, 16 and 256. All right, so 256 we're not gonna use, we're gonna start working with 16. Okay, so which number times 16 still fits, what is the highest number times 16 that it still fits 56? So in this case, 3 times 16 we're gonna have 48. Okay, so we know the first number, the first digit in hexadecimal, that is the number 3. All right, so we're gonna do then 56 minus 48, and this will return us 8. Okay, now to the second digit in hexadecimal, we're gonna think which number times 1 return 8. So in this case, it's the number 8 itself. So basically, in the end, we got the hexadecimal value. So we know that 111000 in binary is the same thing as 38 in hexadecimal. Okay? Now, exercise 8, we're gonna convert 880 in octal to binary. Okay, so again, the same idea, convert octal to decimal and then decimal to binary. So we know that, oh sorry, it's 88, not 800, 88. So here we're gonna convert 88. We know that there is 2 digits, so we're gonna create a table with 2 columns, 1 and 8. And we're going to multiply the digits of the number with the respective columns. So we're going to have 8 times 8 and then 8 times 1. And then we're going to sum the result of this multiplication. So we're going to do 64, that it's 8 times 8 plus 8. So we have 72. Okay, so 72 in binary. Now let's convert 72 into 72 in decimal. Let's convert this into binary. Okay, so let's create a row, a table, and we're gonna start from right to left, adding the numbers that still fits 72, and these numbers will be 2 times 2 power of something. Okay, so we're gonna have from right to left 1, 2, 4, 8, 16, 32 and 64. This is the highest number that we can have. So now we're gonna start multiplying by 0 and 1 to get the final value. So 64 times 1 fits 72. So 1 in 64 will be our first digit in binary. Okay, so if we then we're gonna subtract 72 minus 64 is equals to 8. Then we're gonna check the next one. So 32 fits 8. No, so we're going to give the number 0. Then the next number is 16. So we're gonna ask, 16 fits 8. No, the other way around, right? So 16 will receive the number 0 as well. And then the next number we're gonna check, 8 fits 8. Yes, so we're gonna give the number 1 for 8. And then if we subtract 8 minus 8, it will give us 0. So this means that the other 3 numbers for the 4, 2 and 1 will be 0. So in the end, 88 in octal is the same thing as 1001000. Okay, sounds good. Now let's do the exercise 9. So here we're gonna convert the number 100111 in binary to octal. So now we're going to do again, convert binary to decimal and then decimal to octal. Okay, so let's put all the digits in our table. So we have 100111, and we're gonna create another row where we're gonna put the 2 power of the numbers, so until power of 5, because we have 6 digits. So from right to left, we're gonna have 1, 2, 4, 8, 16 and 32. Then we're gonna multiply these 2 rows. Okay, so we're gonna do 32 times 1, 0 times 16, 0 times 8, 1 times 4, 1 times 2 and 1 times 1. And then we're gonna sum all the result of this multiplication. So we're gonna have 32 plus 4 plus 2 plus 1, and it's equals to 39. Okay, then we're gonna convert the decimal number into octal. So we're gonna convert 39 into octal. Okay, so we're gonna create a row where we're gonna have the numbers that are still fit 39, the power of 8 that still fit 39. So we're gonna have 1 and 8. Okay, because the other number it's 64, so it doesn't fit 39. And we're gonna think which number times 8 it still fits 39. So 4 times 8 is 32, so 32 fits 39. Then we know the first digit, so we know that the first digit will be the number 4, okay? And then we're gonna subtract 39 of 32, 32 of 39. So in the end, the result will be 7. Next, we're gonna check which number times 1 returns 7. So it's the number 7 itself. And then we finally finish this conversion. So we know that 100111 in binary is the same thing as 47 in octal. All right. And now let's do the last problem. So we're gonna convert 1 being hexadecimal to binary, okay? So again, the same idea as we were doing so far. We're gonna convert hexadecimal to decimal and then decimal to binary. So we're gonna convert the number 1b. So we know that we have 2 digits, so we're gonna create a table with the row where we're gonna have 16 power of 0, that is 1, and 16 power of 1, that is 16. And then we're gonna multiply these 2 numbers, these 2 columns, with the respective digits. So we're gonna do 1 times 16 and b times 1. But what is b? b is the value of 11, so we're gonna do 11 times 1. And in the end, we're gonna sum 16 plus 11, and we're gonna have the number 27, okay? Now that we know the number in decimal, let's convert this to binary. So here, we're gonna create a row with as many numbers that 2 power of something contains, number 27. So from right to left, we're gonna have the number 1, 2, 4, 8, and 16, okay? And we're gonna start thinking. 27 minus 16, it still fits, so we're going to give the number 1 for 16, all right? So on position 5, 2 power of 5, we're going to give the number 1 in binary, okay? And we're gonna do 27 minus 16, and this returns us 11. Then let's see the next number. So we have the number 8. Number 8 fits 11. Yes, so we're going to give a number 1 like here as well, the digit 1, okay? And we're gonna do 11 minus 8, and this will return us 3. The next number is the number 4, so 4 does not fit 3, so we're gonna give the number 0. Then we're gonna check the next value, that is 2. So 2 fits 3, so we're going to give the digit 1. So 3 minus 2 is equals to 1. And then the last one, we're gonna check if 1 fits 1, and this is also true. So in the end, we're gonna have the number 11011 in binary. So we know that 1 being hexadecimal is the same thing as 11011. Alright, so these are some of the exercises. If you want more exercises, let us know. We can record more videos, or we can think about other content about this. Alright, I hope you enjoyed this video. Please give us a thumbs up, subscribe to our channel, and see you in the next video. Bye bye.